not even have realized he was doing it from Git.
Right. Okay. So. Sorry.
Sorry. You need to give me more warning.
I'm not sure what more can I do than wave at you and tell you, okay, we'll discuss this afterwards.
You were sharing the screen, I couldn't see you waving.
Oh, yes, the screen sharing. I thought that's a good point. All right, so screen sharing. All right, so a bunch of things that I think we should discuss today. So I added some of them without much warning to the people that probably care about this. So the first item is the CRUD operations and the 107 stuff. So it's actually summarizing some quick discussion Chris and I had yesterday. Then point number 2 is seriously big. It's this whole discussion that started with regards to checked versus unchecked exception, and where I backed off and I realized actually maybe the issue is talking about exceptions altogether, though I'm not quite sure yet. Then there is the CI as a service, the Travis stuff. If there is anything to discuss, I'm not quite sure. And then there is this thing that just happened right now, which is try to provide support for Eclipse and Gradle and whatnot. If only people would stop using Eclipse, life would be so much better. Alrighty. Okay, so on the first point, I guess the important bit there. All right, let me try to say those things out loud. I'm not sure it's an awesome idea. I'll share my ID afterwards, certainly for point 2, because I've done some homework. But on the CRUD things, since this is the things like the first big API that we're trying to spec right now, so JSR 107 comes in 2 variants for any given simple CRUD, which is a get, obviously being a get, but you got a put that is you can do a get and put, where the put returns void and the get and put returns the old value, and so forth. So same with remove, right? Remove returns void or returns the old value, which obviously not having to return the old value like lowers the amount of bytes you have to move around if the cache is anything more than on heap. So, right. So what is our stance on this? So Chris and I discussed this quickly yesterday, and what we think we should be doing for now is settle on the ones that don't return and not have the other ones yet, because actually there are ways to implement the other ones based on other APIs that are coming down pipe later. Yeah, what?
That and there is an argument, I won't make a claim right now for how strong that argument is, but there is an argument that if it's really a cache that you're using, there is no place for the other operations.
Right. Why would you care about the old value? If
a remove isn't a remove, it's an invalidate. A put isn't a put, it's a
update.
Validate an update. This is the all you're. I mean, when you're doing a remove from a cache, what you're saying is something about the value that was there. This value is no longer valid. If it's no longer valid, why do you care what it was?
Right. So that's the stuff that we've been discussing. So except if somebody has a strong feeling that no, we need to tackle the other methods right away, I doubt this will be the case. It doesn't seem like a crazy thing to say that for now we'll just do it that way.
If there's anyone watching.
Yeah.
If you're watching a recording of this, it's too late. Tough.
Whoa, no, be loud on the mailing list. See, there are 2 viewers on this. I have this Q&A app enabled every time. I have no clue whether it works or not. So suppose if somebody wants to say something, they can. And when I started this time, it actually told me there is this awesome new feature where people can actually upload somehow. Can I? We can't. Crap, I would like to upload myself, but I can't. Not really sure what this does. Maybe crashes the darn thing. I'm not sure. I just did select. Currently answering agreed. So I'm not sure. I just clicked done. I have no clue what I'm doing. Mathilde said that to us. Agreed. Not sure whether other people saw that. Maybe something happened, or maybe everything burned.
What does she agree with?
I don't know.
Oh, agree. I think she's agreeing with the statement, the CRUD operations statement.
I guess.
We'll stick with the other ones first.
Oh, communication is so hard. The good news is that, anyways, there is another channel where we're hanging out all the time, and that's the Ehcache on Freenode. So anybody can just come around and do stuff there, and that's good. All right, so let's do that for now, right? What we then do further down the line, we'll just embrace the fact that we don't know yet, and we'll see when we get further down the line. That's certainly my opinion. I don't really have a strong opinion yet. I just would like to keep basically the amount of work minimal, and that we implement this as we move forward, and can then play with the whole thing. Cool. So point number 2. This one's fun. So that's the. Let me try to again share my screen. Obviously, I'm not ready, so I can go to presenter mode. All right. So to recap quickly. This all started with the oh, Mathilde says she agrees with your statement, Chris. I guess the one about the
if it's a cache, you don't care about the
right, yeah.
return.
So
it's not a very nice QA app.
No.
I think it's because Mathilde should be asking questions that we can answer.
Maybe.
Maybe. I don't know.
We don't know.
I don't know if you can even answer them.
Apparently, I can click select, and then selecting question, please wait, and then it says I'm answering, but I have no clue where I'm supposed to type or anything. Oh yes, I'm supposed to talk and say I'm answering your question, probably, and then say done.
Ah.
Right. So much on that. I was expecting I could type. This is why.
Oh yeah, because you just did that. Now you just clicked the. Yes, okay. And then when she said Chris's statement, that just appeared on the answer questions because you must have clicked done.
Oh my god, we'll never.
So basically, the answer questions and questions is there for the.
I don't know.
People who are going to ask a question, they can look at the list of asked questions and see.
You know what I'll do? It just pisses me off with 2 viewers. I'll just say if you to join. Here's the link, because that's too complex for me. Technology. I'm never going to get used to it. All right, cool. So point number 2, the whole point number 2 started with the, all right, in anything but a heap cache, things can go wrong, right? Accessing data can actually go wrong. And until now, Ehcache was throwing cache extensions for about anything and everything.
Mm-hmm.
It's something we, like, many of, hey, Mathilde, welcome. You're now on YouTube. Watch out that you don't have any copyrighted material on your back or anything.
Come back.
Because otherwise we'll get sued. Okay, so what was I saying? So yeah, and that's, we don't like this, and we wanted to clean that up. So a bunch of things can go wrong. The list is sort of endless. I mentioned a couple of points depending on certain topologies. So to recap quickly, if you go to disk, it could be that the disk's full. It could be that the representation of the class, of the serialized representation of this instance can't actually be deserialized back because, I don't know, you were doing a rolling upgrade and you were like 2 versions ahead and you don't support this old version.
Or you're
it just happened that
the
nobody
wrong context
touched it since.
Class, or you got the wrong spread context class loader, or
yeah, bunch of things that's disk. Then in clustered environments, it could be that the node that's the, say, the authority for this key cannot be reached. All of those things. So basically the reason I was in favor of checked exceptions is because I want people to think and not stick their hand in the sand and pretend that everything's going to be fine and everything's going to work and the world is all pink and we got unicorns and whatnot. All right, so then this whole discussion degraded quickly, and I actually sort of not really U-turned, but so when I wrote those example code, I wrote this resilient cache class as an example where I was kind of showing how I would expect people to deal with those failures. And then when I had those two words next to each other, resilient and cache, it was like, this is wrong. Like a cache should be resilient. You shouldn't have to come up with a resilient cache. And then the parallel came up with the cache loaders and cache writers, where basically it's really hard to implement a cache aside pattern properly and make sure that stuff remains coherent and consistent. So this is why you have cache loaders and cache writers. And I thought maybe we can do something along those lines to actually do the resilience of the cache. So we had a quick chat on that, some of us. I shared it in the mailing list. Nobody said I'm crazy and this would never work, even though I think I'm crazy, but maybe it may work. And host screen one, no, that's, I guess, IntelliJ. So that's a shot I took at writing this. So I guess the important bit is none of the fields, none of the interfaces. The important bit are those methods. So how do I best do this? Obviously, I can't collapse it, so you'll be looking ahead. That's really bad. Let me do it this way. So get is somewhat simple, I think. So this is all using lambdas, and because it made it like more concise, I think, for reading what's going on. I hope this doesn't throw too many people off. But so basically what I do in a get is I'm querying the store for the value it may currently hold, potentially passing in, so potentially telling it how to load the value if the value is not there. So this is a method I wrote that just makes it, you can look at the method, it's really straightforward. So if we have a cache loader, load the thing, otherwise return null, right? So that basically, let me go back up here. Right. So basically what I do is try to compute, give me whatever you have in your cache. If that's not cached, use the loader in order to populate the cache. And if the loader returns something, eventually the cache returns something, then return this value, right?
Yep.
That's probably straightforward.
Beware of accidental capture.
Yeah. Right. That's because, yeah.
Yes.
Anyways, it annoys me already. All right, and then all that happens. Why do you want to confuse everybody? Like, this is just stick to this. Otherwise, actually, I think
that's actually really scary, because what if it...
All right, whatever. That's not the point. So reload this, right? That's what we're trying to achieve. Now, if this goes wrong, what we want to do is remove what's there. So take the example.
Do we?
I think you do.
Why?
Why would you leave it there?
Depends why it failed. Yep, it depends why it failed.
I actually had noted this down as something.
So here's the thing for me.
Yes.
The decision about that should be being handled at the store. Because the store knows more about why the failure, which is the information you need to know about whether.
One thing that was slightly unclear in the I guess Mathilde looked at the code. So what was so we have this exception that has a subtype that's permanent partial cache access exception, where basically what this is trying to say is that the cache is not entirely down, but this thing you're trying to access, we cannot access, and we will never be able to access it ever again.
So there's something wrong with this, the value at this key, with this
mapping.
So
I think in this particular case, this is where you want to see the remove happening.
Yeah.
Right? This thing's dead. Think of the serialization.
Right, but
okay.
You only need that kind of to me, one of the main reasons that kind of hierarchy needs to exist is because you're not handling the exception at the point where it occurred. So you need to be able to communicate information about the nature of the failure back up the call tree. But in this case, you could handle it at the point where it occurred.
No, right. Okay, maybe I forgot a couple of things. This is like all the solutions, i.e. how we handle the failure is hard-coded here. But the point was to actually come up with a strategy, right? So that it becomes pluggable.
Right.
So it will never really be handled at that stage. No, arguably it could invoke a different method that says handle this unrecoverable exception or whatnot, right? So...
Well, then we can substitute the same argument. Where does the strategy get called from? Is it called here?
Yeah.
Or does it get called
in my books, it would call from the cache, not from the store. No.
Why? Sorry, I'm being obstinate and asking.
No, that's fine. Because I think to me, conceptually, it sits at the same level than the cache loader, cache writer, and all those things.
Okay, so you want to do this,
and I want to convey something to the cache so they can decide what to do, right? So
that's nice because it's simple to understand how the structure is being used. Yeah.
So one example of that is this here, right? So, all right, everything failed. It's fine. I'm gonna hit the if. This should actually be if. Be correct, but anyways, I'll pseudocode. So what we do here is basically
why is that not load if required?
Sorry? This if this fails, if the read fails, this will not be invoked.
Right? What is load if required? But what does that method do?
It loads. Oh, why is it not load? Oh, okay. All right, this meeting is going to be...
I'm sure the effect is equivalent, but it feels, yes, like that should be what happens.
It's, again, the important bit is, right, and it should be returned because Chris doesn't like...
Because this is not
this kind of coding. All right. Anyways, so we got one problem here, right? If the remove fails... Okay, well, we got an issue here. If the remove failed, this thing's still around, and it's probably not awesome, but nobody's gonna die from it, right? So we're still this memory is still being used, or it's still things on disk and blah blah blah, but nobody's gonna get hurt from this. So the get seems to indicate that this whole strategy thing is not too crazy. Now, if we go to a put, things get a little bit more hairy because so exactly the same happens, right? You do a put. If needs be, I'm going to write back to if needs be, I'm going to write this delegate to the writer, right? And populate. So that's basically compute, whatever, whether it's there or not. I'm going to write this thing if need be, and I'm going to store it in my cache, right? Makes sense?
Don't you have to do a write if required?
What?
On the cache.
Yep. Yes, probably. But anyways.
Well, I say that because there's an interesting race coming up, then, isn't there?
Yes. Well, that's what I'm getting at here. So you can drop this thing on the floor. Well, so. Yes, there is a race. There is... So if, again, this is a cache access exception. Is it temporal or is it permanent? I think this plays, again, an important role, right? Though there is still a race open, right? Somebody could come around and do a remove that succeed. The equivalent is what we're trying to do here, and somebody does a replace, does another put, and this whole thing becomes racy. Leaving that aside, if the remove fails and we write to the system, right, then the old value is still in the store. If it's a transient failure, right, if it recovers, right, I got basically k equals v1 in the k equals v1 in cache and k equals v2 in store or in system of record. And that's a problem. So what do we do with that?
The only person that knows the answer to what you should do there is the user.
I think so too. So what does this mean?
Throws the exception. I think. I don't see. I mean, I actually no. I think it has to be. I think it should. No, it should be more than a cache access. Well, because the exception you'll get there is the exception thrown by the store saying it couldn't remove. If you do a put and you get an exception saying we couldn't remove from, you're going what? It
No.
follow
Yeah.
some kind of.
All right. All right.
It should be an exception that indicates cache write failures, possibly inconsistent.
Right.
Something like that.
Right. And so we get back to the whole check versus unchecked discussion.
No. What? No. Oh.
Well, what kind of exceptions does he throw there?
I just wrote that. Line 63 is just...
No, I know. But so
for the fun of writing some exception.
So what you're showing here for me is that going with that strategy is going to be complicated. And it's not easy and free and whatever. It doesn't mean that we can't have options and still build that idea of resilient cache.
Oh, the strategy can still exist, yes.
Oh yeah.
But you can't. But it is impossible to build a resilient. Well, not impossible. It's, at least at first glance, it seems to be not possible to build a resilient cache that is completely resilient.
I don't know. Can instead of catching cache access exception, can we catch more specific exceptions that then tell us what are?
But what do you do if the remove
options
fails?
It's irrelevant, Louis. At some point, you get to some catch block that catches some kind of exception, where basically you're like,
I'm lost. Yeah, I'm screwed.
Well, you're not screwed. You can make the strategy really specific, and at that point say, strategy dot failure to remove after succeeding at putting to authority or to system of record.
Yeah, I think
This is the exception I failed with, right? But the problem is, one of the things we thought was powerful about this approach was we thought that it would be possible to write a solution. It may be possible to write a solution that works for 90+% of the people out there. But what we're discovering is that we just hit this point where Alex and I both looked at this and thought, well, who knows? 50-50, it seems. No one. There's not one. When I look at what to do at line 63, I can't think that there's a solution that would fit 90% of the people out there. And if that's the case, then you're basically going to force. You've got your choice. You either force everyone to write their own strategy, and you provide some abstract superclasses that implement the vast majority of stuff the way 90% of people want them, or you force people to write exception handling at the call sites. Either way, it's the same amount of coding, just traded to different places.
I think that's just too complicated, in fact. The idea with the resilient cache is a good one, but it's just too complicated.
So what would you have it do instead of what would you load it?
I will let the user decide. I will throw the exception in each case, in the get, in the put, and so on.
So not even bother to do the catch, not even bother to do say the remove at 61.
Yeah, but we will fail. If we try to be smarter than the users, we'll fail.
But you're also pro runtime exceptions.
Yeah.
But they won't get caught. Which is the antithesis of what Alex. Because the reason Alex likes this is he's of the opinion, and I think I agree with him, that if the thing is going to, if a cache fails, it shouldn't be fatal to the application. It's just a cache.
We don't have to decide that. Let the user decide. If my cache is my primary record,
it's not. It's the cache.
You don't know.
Well, so the whole. One of the things.
I'm okay to propose a second interface with stuff like that, or something with checked exceptions, but not the primary.
I think you just said one thing that looks strange to me, Chris.
Mm-hmm.
It's just a cache. No, it's no longer is. It no longer is just a cache, because it's a write-through cache.
Right, but the write-throughness worked.
Right, the write-throughness worked, and it will all be fine for as long as
wait.
what creates this exception doesn't go away, right? So if you can't remove the old value, right, the old value remains in there. If the old value remains in there but is never reachable, nobody cares. Well, right.
No, but
I would
that's
not
not what I'm saying.
You don't know.
What I'm saying is that we are, when we do write through, we are in a situation where it's not just a cache.
Okay, let's replace this.
It allows, I think when you reach that point, and you know you have a writer and you know these conditions, yes, you throw the exception at the user, because it should probably fail the application because you just created an inconsistent state, which is different than when you have the cache aside pattern
Well, you
and
can
your
have,
cache fails.
No, you can make this cache aside too and have the same problem, because with cache aside, what you'd have done is you'd have done the write to the authority, and then you'll go to update the cache, and that fails. You have the same issue. The cache update failed. I have the danger here of exposing an inconsistent state. What do I do?
You let the user decide again.
Right. Great. But if you throw runtime except, but now we're getting into the runtime versus checked. But to me, for runtime exceptions, you are allowing the user to easily abdicate responsibility for fixing that problem.
No, you're not allowing the user to abdicate
You're
responsibility. Yeah, not even.
You're saying
I'm not sure.
This is a runtime exception. You can't handle it.
Hey, by the way, you can do a get on me, and by the way, it can also go very wrong, but I won't tell you. That's what you do.
But okay, so it sounds like Alex's idea is
Dead in the water.
bleeding badly. It's not dead. It's bleeding. I think that there's the potential, because forget it works. So to me, there is a potential that.
And I was about to say there is more that actually works, to be honest, right?
Yeah.
Because this problem, so I'm inconsistent, can only occur in two cases.
Yep.
One, you're distributed, right, and you're partitioned.
Yep.
Two, it's a transient failure, right?
Well,
For some reason, let's say you mounted your disk persistence on NFS. Did I really say this?
I think for another reason it could fail.
Shoot.
It could fail if you can't do the key comparison. For some reason, if there's some exceptional condition that prevents you from doing the remove, basically there's something screwed about the key, like you can't deserialize it to do the comparison. You'll never be able to strip the key out. Now, it's fine, that's permanent, but there are other reasons why, there are multiple reasons why the remove.
Yeah, well, whether it's permanent or not is go figure. It could
suddenly start working, depends on what the nature of the failure.
Yeah. So,
but it sounds like, to me, I like what we're talking about here, but to me, I think that I think it's bleeding in the water, but I think you can fix it. But the way to fix it is to get rid of it as a strategy and hard code it into. So I think, for example, the get code. I like that, and I think that's the way the get should operate.
Yeah.
If it fails, if the get fails and there's an access exception, I think it's totally reasonable to have the default behavior be to try and blow it away, maybe, or at least optionally. But it still leaves us. But the way that it's bleeding, there's still blood in the water. We still have to decide checked versus runtime, because we're going to have to throw some. But that's back to what we discussed before.
Well, either that or the
strategy.
So basically, the reason that what I see is basically two things, right? It seems like there is always something that happens here and here. It's a pattern all over the place. So that's to replace. This one's maybe a little bit more confusing, but you end up with the kind of same logic. Is this here? Oh, sorry, no. There are three places. Here, and that's kind of the finally. And so the put doesn't have the finally because. Oh, actually, yeah, it does. I just forgot to do the write if required, as Chris pointed out. So the same is true here. Crap, what was I getting at? So it's here, here, and the finally. So that's finally here again.
Yeah, there are races in the right if required as well. Well, I'm not sure there are in the path. Because you can't...
Right, but okay.
Anyway.
Right, they might, but this is another discussion that we can have further down the path. What I tried to do is basically write everything like non-blocking in the cache for now.
Yep.
I'm still in the hope that it's feasible. Don't get hung up on like what you read there. Okay, so maybe I should have used locks to make it like really explicit. But.
Is there agreement that we have to throw exceptions, or do we think we can delegate the stuff to strategies again?
Right, that's what I was getting at. So what we can maybe do is for simple caches, right? I think simple encompass everything, but that's not distributed, probably. I think we can come up with the default strategy that just handles everything fine so that we don't need to add any exceptions. And the reason we want checked exceptions, when we say we, I think Chris and I sit on the same boat here, is because we want to create the awareness of the thing that can go wrong all of a sudden. So maybe instead of doing this way, is to basically get rid of the this default strategy in that case, right? And force someone to come up with one. Even if it's something like where he needs to decide, like, I'm using the throw inconsistent cache exception, right? Which could be runtime, but he typed those things somewhere, right? We can come up with additional wrapper things into a cache that catches this one, transforms it inside check one if he wants to, or a bunch of other things to cope with that exception, right? Because one of the key things with the distributed one is being partitioned, right? And I fundamentally believe that in every distributed system you want something that actually gives you this piece of information, whatever, potentially prior to the inconsistent cache exception being thrown, right? That you know that you're partitioned. Right. So what I'm trying to say is that maybe there is more to all this when you move into those waters, anyways. Did that make kind of sense?
Yeah, Mathilde, with the remark that 90% of the use cases will be simple, you're right. But what Alex is now proposing is, I think, that if you're a simple topology, you can feed in the default strategy. You can use the default strategy without needing to add code. If you're a complex topology, you'll be forced to provide a strategy which there are no concrete implementations for. There are abstract implementations, and you extend one, and then you must specify what the behavior is.
Yeah, I understand that, and I think that's a good idea. But it should be called something like resilient cache, not Ehcache, because that's that.
Oh.
It shouldn't be the default. That's nice features to have, a resilient cache and stuff like that, and I totally agree with you. But
so
it will be as a feature.
So how should the base if that's resilient cache and not Ehcache, how should the Ehcache behave?
In fact, we're speaking here about an implementation. Okay, I'm here more because of the API. Okay.
No, totally. Well, okay. Sorry. If resilient cache should behave using strategies and this approach, how should the basic simple cache that 90% of the users would use behave? What should the API look like?
Not to be resilient, just fail and it's the exception. The simple cache will just be a dumb cache, and if it fails, it will throw the exception to the users, and the users will decide what to do. I'm not saying having a resilient cache is not a good stuff, but for a simple cache, just say simple, really simple. That's not simple.
But you don't have to look at this.
Of course I will.
Well, close or said.
I mean,
you will have, we'll see, but you will have problem here too. So I think it will just complicate. It just complicates. It complexify everything. The only thing I like with that is that you don't have the checked exceptions. And if we do that, we're forced to do that for the principal API. So
I mean, in which case, for the simple cache, you can just get away with not having the strategy or having any of this stuff and just throw runtimes everywhere. And not bother to have the... Because in a simple cache, it's highly unlikely that any of this will fail. So then just get rid of it and just have it as it is.
But can't we say that we use the resilient cache pattern even for the simple cache, and it's just as since the simple cache doesn't have all these connectivities,
paths.
It has a sorry?
You won't go down those paths, you're right.
No, you won't go down them. And for example, the cache with writer becomes a more complex cache, and you need to specify a strategy that the default strategy won't cut because of these paths appearing as possibilities. And then if you do it like that, then it's simple, but everything is in there. And so you could even end up having a simple cache where you actually change the strategy, which I think, yes, it's added complexity, but it's added complexity the moment you look into it. If you never need it, you don't have to look into it. It has a proper default. And the proper default could be something which is better than just throwing any exception to the face of the user. It's something that will try to do what a cache should do. And like Alex said as an initial statement, if you fail to get from the cache, if you fail to put from the cache, why should you crash the request of the user? The request in the user's application.
Right, because I used the web app as a simple case, because this is where it sort of hurts the less. Though arguably, potentially, it will hurt one user a whole lot. I don't know. But in other apps, that can be lethal, right? I mean, and I think that's the very fundamental difference between. Because I think Matilda asked me the question on. So I started the discussion with Max. I think when Hibernate moved away from checked to unchecked, it really made sense, right? So what is it you're gonna do, right? Your database down. Well, what is it you're gonna do with this exception? It's nothing you're gonna do with this exception. Furthermore, like because of the whole model, it could be that while doing a query, you flush things that violate some constraint. It like all of it, in my opinion, becomes like way more like much harder to think about. In this case, I think it's simpler. And again, I won't say it's a thing aside, but you know, I believe that you're better off degrading the performance of the experience of the application rather than crashing entirely. I think this is bad. You shouldn't do that. Not sure who's calling, so I'd rather mute.
Yeah, I was going to do the same. You were faster.
Don't want to hear. Yeah, don't want to hear things I might regret afterwards.
And save them to YouTube.
And save them to YouTube, right? She might thank me for that at some point. Okay.
I mean, yeah.
We're sort of running in circles here. I really don't know what to do. You know, because when Matilda, I muted you. So if you want to talk in, you need to unmute. I just didn't want your conversation to be recorded.
She's obviously
she left.
Obviously insulted by that statement.
Yeah. Not knowing who was calling, I thought that we better like. So
are we really running in circles?
I don't know. It's like to me. Again,
no, I think you showed something that makes us move towards a more evolved solution, and the problem is, where do we stop? Where do we say, guys, this is becoming so huge that we can't do it?
So this is where so the situation I'm at. I think that, okay, here's where I'm picturing the world at the moment.
Oh my God.
Oh God, yes. Here goes. I think the strategy idea makes sense, but I think that there are 1, 2. Oh, maybe this is a bad idea. I think there's a bunch of different modes of operation that we need now. I think that.
Oh, remember,
those...
among all those ones, there is the default one, right?
Hang on. Right. So I think that there's the resilient cache mode, which we talked about, and then there's which. So okay. So if you consider, so we talked about the internally we would use checked exceptions.
Mm-hmm.
So to me, the mode that I'm starting to think still exists is the mode that just exposes all those checked exceptions out.
Okay.
Because I like checked exceptions, and the more the better. That obviously really annoyed me. Bear with me. The next mode is resilient cache, which says I am going to attempt to handle if there's a failure. So basically, the checked exception mode is if there's any kind of failure, defer everything to the user, let the user figure it out. Then there is the resilient cache, which is if there's any kind of failure, do your best to handle it. So if it's a failure on get, then maybe try and invalidate, maybe try and remove the key and then return null or invoke the loader or whatever, depending on whether or not there's a loader. So that's for simple topologies. For more complicated topologies, where resilient cache can't be fully resilient, you then have to choose what you do at that point. So you basically have full exceptions. Show me all the failure mode. Then you have resilient cache mode, which is hide as many of the exceptions as you can, handle as much as you can internally, which for simple caches will be everything, we think. For more complicated caches, is not everything. And then at that point, you have the point where you have to force the user to handle those exceptions. And I'm torn between saying that is something you do by extending a strategy, or that is something you do by handling the checked exceptions being thrown out at you. That you throw inconsistent cache state, or potentially inconsistent cache state, or something. Does that make sense? I don't know which one of those is better. I kind of prefer...
Which one's the default?
I think that the default is the one that is resilient. So for simple people, that's
not good.
Users with simple use cases and simple heap-only caches, their default usage is resilient cache. There are no checked exceptions being thrown. Maybe we throw... I don't know. Well, you can decide how to handle the possible bizarre scenario where you manage to persuade a heap cache to go down one of the weird paths we didn't think it should be able to follow. You could throw those as runtimes, I guess, maybe, because it's kind of like an assertion error. So the default mode is resilient cache, which for simple cache users means they don't have to worry about exceptions. It just works. And that for complicated users, they have to worry about only the complicated cases which the resilient cache can't handle. It basically says, well, I tried my best, but I can't hide this failure from you. You really need to decide what to do here. Whether that decision making is something they have to do by writing exception handlers like cache blocks, or whether it's something they do by writing handling methods that go into a strategy or what, secondary question, I think. And you have the option, if you wish, to go to full-blown, anytime it fails, I want to know mode, where it throws checked exceptions at you all the time. And you say, I don't want you to attempt to be resilient. I think I know better. I want ultimate control.
Are you arguing for resilient cache being the default one, though?
Yes. Because I think that does two things. I think that the resilient cache with the heap topology, I think Matilda is right. It covers 90% of the use cases, the vast majority of open source users out there. And I think that resilient mode where it throws when it gets to the point where it realizes it can't maintain a consistent cache and it needs the user intervention. Whether that's a throw or a defer to a strategy you have to implement, I don't know yet. But it basically, the point where it's resilient until it can't be anymore and defers to the user, will cover another 9%, gets you to the 99%, and I think the third option of the throw everything as checked mode will cover everyone else by definition, because it gives you ultimate power, but and it's something that's very simple to do because it's basically exposing what's going on internally. I think it's almost zero cost option to present, because we're going to have that internally, because the resilient cache is going to lay on top of it and catch with exceptions. That's where I sit, which I think delivers what we want, because 90% of the users don't get to not think about exceptions. 9% of the users only have to think about exceptions when really bad stuff goes wrong, which they should be thinking about anyway, because at that point, if they don't make a conscious decision, their potential behavior is really bad and breaks their application.
Yep.
And you only have to deal with all of the shit if you really want to. And at that point, your problem. Deal with it. You chose to handle everything explicitly.
But then it's very explicit.
But it's very explicit. It's checked everywhere, and you must write all the handlers.
Yeah.
All the cache blocks.
All right. Well,
you look unhappy.
Who is you?
You.
Me?
Alex.
No,
You look beleaguered.
I don't. No, I don't.
Or
Are you uneasy with the fact that we end up categorizing the strategy into simple and complex failure patterns?
No.
Because I think it makes sense. I kind of like it, actually.
I actually, so my position on that in terms of splitting between about how you decide how to handle the failure cases in the case of a complex resilient cache, I would actually make it so the strategy is not pluggable.
Right.
And it's hard-coded, and you throw the checked.
Because basically this I'm on consistent state, right?
Yes, it's
only
what you're saying
reach
is
in very specific topologies.
There are now three interfaces: simple cache, complex cache that throws inconsistent cache exception, which is checked, and I'm a crazy person that's paranoid cache, which throws all the checks.
Right.
Yeah, but so we make a conscious decision of not allowing you to quickly replace one with another in your application.
They can all. Yes.
Yes. If you go the strategy route, it still works, right? Because if the
but if you go the strategy route, you don't get that checked inconsistent cache exception. Yep. Because on an interface, because the moment you do that, then it comes back even.
But here's the thing. This is back to the scale continuum thing. How do you transparently move up? And the answer is, if you think you need to transparently move up, you don't code against the simple cache interface. There's nothing to stop you. I think we should allow people to use to get a reference to a heap cache as a complex cache.
Okay.
If you know you're going to need to scale up, then start thinking about it now. Code against the complex cache interface, handle the inconsistent cache exceptions, figure out what you want to do in those situations, and then your scale up is transparent. If your scale up is not, if you choose not to do that, the reason it's not transparent is because you have extra decisions to make.
Yeah,
it's not compiling compatible for the hell of it.
The thing is, I still would like, and it may be wishful thinking, I realize. Huh? So, and I know Alex has been the one doing the tryouts and stuff for the moment. But what I really liked in the whole discussion about that resilient cache was that we would still push the issue to the user, but like upfront. Because suddenly you're trying to create a clustered cache that has, which is cache through, so it has a loader and a writer. And when you do that, at the moment you do the initialization, we tell you you need to specify other stuff. We expect you to tell us which strategy to pick in that case. And in the end, the interface you get and the one you work with is still just a plain cache interface that could be switched back to.
You could. I mean, when I originally stated it, I said I was on the fence as to which is better.
Mm-hmm.
I think so. To me, the plus argument to coding to forcing to code a strategy, and I think actually they would be. I would still go with the fact that the strategy you implement is a inconsistent cache handler, or here's an inconsistent cache state handler. You only get to choose the behavior for the inconsistent points. You don't get to change what the behavior is, the standard resilient behavior.
No, the rest are different options if we provide multiple options.
Okay. So I guess the advantage to that is you get to decide it up front, which means that you don't have so much stuff change in your compile time dependencies. And I guess the only disadvantage to that is, well, there's two disadvantages. One is it's a bit unfamiliar to people.
Yeah, okay.
And the other is you don't get to customize by call site as easily. You might want different behaviors on an inconsistent cache depending on what the operation was, or what the data was you were manipulating, or what the two values. Well, I guess you can still do it. It's just a bit weird.
Yeah, you can catch it.
Okay, so what ends up happening is you end up having. If it's really simple, right? You basically take a huge amount of duplication of all of your cache blocks potentially, and factor it all down to something really small and simple. But if your cache blocks are all going to be different, you may end up with quite a large convoluted method.
Yeah.
The handler.
Yeah.
Yeah. Your use case drives that, not our API.
Mm-hmm.
Well, the question is, which use case is more common?
I think
that drives which one you should choose.
Which use case is more common in which category? In the general use case, because we don't even get there.
Well, if you have a use case where you must handle the inconsistent states,
okay,
which is more common? You handle them all in exactly the same way, or you handle each one individually in a large enough number of different ways that your handler method ends up looking quite complicated if you're forced.
Honestly, what can you do really?
The handling depends. Yeah, the handling will. If you can do something, it will be located in very specific parts of your application.
Yeah.
But then,
when the cache told you
the
to be consistent, one of the things you could do is, I scratch completely the cache and not ever go through a cache anymore.
Yeah.
And that
I guess this is kind of the discussion that Chris and I had, which is the whole thing about when people complain they don't like checked exceptions because it pollutes their business logic with the exception handlers. And sort of the counterpoint to that argument is the exception handlers are part of your business logic.
If your exception is a business exception. At one
I
point,
would argue that's still part of your business logic, but maybe not. Well, the application logic at least.
I don't know. It depends.
Well,
and if they don't handle them, whether the runtime is checked.
I don't think it depends, to be honest. My take is in the distributed system, they're part of it. And if they're not, it's because you didn't design the system well.
Okay.
It's right, but that's what we're talking about, right? We're talking about partitions here, right? So you need to have a business strategy around being partitioned, which could be go down, right? I'm fine with that. It could be reconcile. It could be, but reconcile, what does it mean? If that's a part of your business logic, then I don't know.
No, but then the question is, given that, and I fully agree, should we impose, and even if it's a single one, should we impose that exception? So,
no, I don't think we should, because that's my take. So if you go to strategy round and you get to this point, to this thing that handles this, that by default does nothing with it, just says forget it, because for all the topologies where it doesn't actually mean anything, right? Then for the topologies where it means something, as Chris said, say pretend this needs to be abstract, and somebody needs to write some code in there. Right? You do that. Now, obviously, you can do that and say throw runtime exception foo, and think you're done. Sure, you're making a sloppy job, right? You will never manage to make it so that someone can't shoot himself in the foot.
No. That's not why I'm asking.
You force him to do that, right? hopefully he starts reading on what this means, where this can be thrown. This can all be well documented. This could be documented, maybe. I know. Okay, I was about to fall back to runtimes once, but if we don't really have it, it doesn't really make sense. So right. And anyways, we could like document that well, so that you find those things. Yeah. What else? No. Well, that's basically it. And then just go and revisit those places. Now, if your cache, if every other class in your system has reference to all the caches, then probably this is going to be a pain in the butt for you to handle this thing from
Yeah, but that's probably also...
Now, arguably, if all your classes in your system have a reference to every other cache in the system, see point number one, you probably designed this thing wrong.
So my exactly, I'm fully with you there. So my question was, given these situations, do we think it's worth either having multiple CRUD operations interfaces that are disjoint, because we want to have that inconsistent cache exception be a checked exception, but not put it in the face of the users that don't need it? Or do we think that the added value of having a single cache interface...
Okay, here's my take. I don't think there is any value of having multiple ones if the one that's a pain in the butt isn't the default one. Nobody's going to go from unchecked, not throwing any kind of exception or nothing, to the full, except the one that Chris mentioned, maybe. The one that sits on totally the other end of the slider. That throws like all the time, and you make this conscious decision that you know you're designing a heavily distributed system where it caches some very specific values, blah, blah, and you go to that. Though arguably even there, you could actually write this type tailored to your use case yourself. Around it.
And yeah, it becomes an exercise in...
Hang on, you're saying there's no advantage if the default is the simple one?
Yes, I did say that. Because nobody's going to use the other one.
And so, given what we've discussed, my take would be the exposing of the issue is the configuration bit.
Yeah.
And that inconsistent cache exception, we accept that it's runtime because we assume that people that have been
we don't even need to code it potentially. If all the strategies that we come up with, when you get to where you can reach this point,
the thing you pass
to implement the thing yourself.
The thing you pass to the strategy does not have to be an exception. It can be.
It can be anything.
It might make sense so you can read through it. But actually, no. Make it not an exception.
Yes, that's
indeed a failure context.
No. It's exactly.
That's what it is.
Something like that. It's not an exception. It's a message to you. It failed. What do we do? And it becomes your business logic if you want to check.
Again, when we pass into that, we can see at that point.
And if you want to throw a runtime exception out, then it's up to you to make sure that you catch it on the other side. But it's you that's throwing the runtime.
Exactly. That's the point I'm driving at.
Well, of course, we're not giving them the possibility to throw the checked exception. But.
Yeah. Right, but why would you again? Because it's for you get into this one last percent that might care about that. You please the 99% because 90% will never even ever get this I'm inconsistent.
Okay, so we're talking. So now we're talking about two modes.
I think what we end up with is the logic of having a very simple cache API that doesn't have checked exceptions, so it kind of looks like what GSR 107 proposes. And we have strategies, and by default, you'll get a default strategy. You don't even have to look into how they work. It's just you'll get one.
I would decouple that. I would have said there are two strategies. There's the exception. There's the store failure strategy handler, which I'm not even convinced needs to be configurable. And separately, there is the inconsistent state handling strategy.
Yeah, and that one is exposed to you only when you go to a complex.
Only when you go to one that needs it. Yes. Because the thing for me is, I think that the number of people that need to modify the inconsistent, that need to modify the resilience strategy, are so small that they would be better. We would be better served just saying do
Well-
the easy thing, which is i.e. hard code resilient stuff, so that it gets compiled in much more simply, rather than having to do strategy stuff, and then say you want to customize that, fine. Then you're the person that goes straight to write your own one that wraps around it, the stuff that throws everything.
Yeah, and yeah.
Because I think we can hit, with the ability to modify the handling of the inconsistent state, we can hit such a huge fraction of the user base
Yeah, maybe it's worth. Yeah, sure.
that it's not worth making that part of the strategy pluggable.
Mm-hmm.
What you could do is you could make the resilient cache class non-final, maybe. And provide ways of.
I think what we can do is try to get there with one thing,
Yep.
and then reassess from there.
Yeah, that makes sense.
Not like we need to spec it all out in some doc like now. And
we're over
when you
time.
said like that it shouldn't be configurable, I was actually thinking probably you want two. One that implements this whole resilient strategy and makes sure that basically your cache is a cache that most probably will never fail. If you configure it right. Well, actually, even if you don't configure it right, we don't care. Cache aside, cache through, all works. And if you really want to have exceptions because you care about when things go wrong, you might do it. And then potentially, as you said, like if it's non-final, people can then implement their own overrides that says throw my runtime exception because I like him. And they can then go catch his runtime exception because he likes them.
Yep.
Oh,
Cool. So
wait, this is the good news. Is that basically everything we discussed, I can close as issue 50. We can move on to implement the CRUD and whatnot as we go. This needs to be now part of this, and this will have impact, as you could see from the code that I shared, on the store API. And then we're out of time, but basically I guess what we need to start thinking heavily about is the CHMV8 port for the memory thing, and then see how we port that all to all the other stuff. I know there were other things I wanted to discuss quickly. All right,
does that mean we managed to put some band on the bleeding guy?
Yeah. Cool.
Okay. Quickly then, the last 2 points. Third one, Travis CI. So I didn't look too closely, but basically it does no archiving again. I wondered about one thing. Would we think that mailing everything that fails to the mailing list would be good enough?
How much space do we get? How much space will Google let you use if you...
Do you think there is a limit?
I don't know.
I
suspect there is.
It's an attachment. It would be an attachment. That's not even feasible.
That might exist. You might find that it just starts purging attachments on really old messages. That might not be a problem.
It wouldn't be a problem, I think.
But it depends how quickly it purges them.
Because this is basically where again, like the Travis CI sits at, right? There is the whole thing of publishing the artifacts. I don't think that's an issue.
It might annoy people who are on them. You might want to create a special group for it. Because I might not be interested in being on a group that's going to have large binary attachments continually mailed to it.
Right, then we need it twofold. Mail the mailing list when a failure happens, and have somewhere else to mail send.
So you can make it like Ehcache-failures group.
Right, and anyone
if you want to receive big emails.
What?
If you want to receive really big emails, you can join it. But if not, you can just go look at it.
Right, so I wonder whether that was a crazy idea or not. Somebody thinks about it.
Well, it's either that or we go to CloudBees.
At this stage, I guess that's what this means. Yes.
How much archiving do we get on CloudBees?
I don't know.
Oh, we set up some location where we upload.
Yeah, we could do an upload, of course. But
I'm sorry to ask this because I'm pretty sure you already answered that in the past, but what are the artifacts that you're interested in as the output of each build?
I don't really know, to be honest. Like, everything that goes out to standard out is logged, so that's good. I certainly care about test reports when they fail.
Yep.
I would even argue sometimes I care about test reports even when they succeed.
And so, for example, on Travis CI, you can't view these for anything but the last job, or not even for the last
I
job.
haven't seen that. As far as I can tell, the VM runs your entire thing. Whatever it logs is logged as logs of the build.
Okay, so there is
then
no.
the VM
Okay.
that got used to spawn off your job is killed.
Okay, so it means it's not only just pushing. So it's not just only archiving produced jars. It's also archiving build results that we'd have to set up completely.
That's what I'm talking about. Yes.
Yeah. Okay, I'm sorry.
I didn't focus on any artifacts. The artifacts.
No. I
Yes,
thought you were.
yeah, I
but
think that's the email I sent you because apparently that was covering blah blah, and we know that has to happen. But I know the other thing that we want is be able to, at least when the test fails, I need to know a bunch of details.
Should we just try and see how it happens with CloudBees? And because that
So
maybe
we move on. Okay. So I'm gonna create a task for that, and I think I might push this your way once you're done with the one that you have on your plate for like 3-4 weeks already.
Yeah. Although I think I'm going to close it as it is and just reopen a new one once we found the final location for the build. Then I'll do the Sonatype publication.
It's actually not what's on your plate, I think, or is it? Okay, maybe.
Isn't it the Gradle and
Yeah, maybe. I don't know.
module stuff?
Anyways.
I think that's okay. I'll
Yeah,
have a look.
maybe it's part of that for the publishing in order that we get the snapshots out, right?
Mhm.
So it made sense that it remained open anyways, right? Because until we knew exactly where we were.
Are we going to leave Travis CI running while we try out CloudBees?
That's what I did with all the other ones.
Sure.
I only shut one down when I had another one running.
Oh, I was going to say run them both in parallel until we're happy which one we prefer.
Right, but there are tasks to be handled at this stage, right? Somebody needs to make sure that we archive. Somebody needs to make sure that we
Okay.
save this whole thing. So if we don't do that, we'll never be happy with Travis CI. So the question was now, what do we do? Do we try to do those tasks, or do we think those tasks are too burdensome already?
If we can get free storage in CloudBees and it's tightly integrated into CloudBees, then it seems preferable.
Yeah.
The only other thing to do is to contact Travis CI people and say, hey, what's going on? Is there any way of doing this? If they say no, then and we wait until they say no.
I think I searched for that already. I think the answer is no. Okay, cool.
Okay.
And then the first point was Eclipse and Gradle. So what I would like to know from some Eclipse users, I think Hung did some changes around that. So basically it looks like Eclipse is the only one where it needs to be sort of upside down, i.e. where the build system needs to know about Eclipse. Well, for all the other real IDEs, they know about Gradle.
Yeah.
That's the word.
I believe so. Anthony?
Yeah, sorry?
Gradle expert. Sorry, Eclipse
I'm
expert.
Gradle, Eclipse. No Gradle support in Eclipse.
Gradle. Oh, sorry. Gradle support in Eclipse. Yes, there is a plugin for Gradle in Eclipse. That's for sure.
Does it,
Right, but does it work?
does
I
it
don't
work
know.
natively? Or does it...
To be honest with you, I've never used it. But I
Okay,
know
so
there is
let's stick to the way it is now, and we'll see. I personally hate it when it was that way. It was that way back when for IntelliJ as well, because it didn't have Gradle support, and so you had to always keep your...
Okay, so according to this, SpringSource make a Eclipse plugin, or a Gradle Eclipse plugin.
Yeah, the question is it a support for editing Gradle files in Eclipse? Or is it the support for opening a Gradle project
It's
without having to
importing a Gradle project.
Okay, without having to do a Gradle command.
On the Gradle website, Gradle Eclipse support is developed by the SpringSource STS team. You can use it via STS or install it separately. The Gradle Eclipse plugin provides the best IDE integration as well. It allows you to import Gradle projects into Eclipse. The information from the Gradle build script is used to configure your project in Eclipse. The import wizard is pretty smart. You can do partial imports of multi-project builds. You can also choose different naming patterns for sub-projects. You can even define Gradle tasks that should run before and after an import/refresh. And provides a runner for executing Gradle builds. It's Gradle build scripts, and it automatically enables Groovy editor support for those files.
No, honestly, not that I care really, right? I don't care that there is
No.
this line in the
Well, it
Gradle
sounds,
build.
well, this
I
sounds
just-
nicer
my-
than
Yes.
than what we've got currently, because my understanding from that is that it means you don't have to have Eclipse-specific stuff in the Gradle build files.
Yeah, and that's what I was saying. I don't care about having Eclipse-specific it's a one-liner. It's not like it
Yeah, I know.
leaks all over the place.
Well, it's
So
one
that
liner for the
doesn't bother
moment.
me. But I know that when I had to do that for IntelliJ, my daily experience with it was a pain. So I'm not even though I don't think Eclipse users necessarily deserve
Hung is
any
working
love.
with this stuff right now, so why don't we let Hung try out the one that I just linked to and see how it works. If it works really well and it's great, then maybe we can take out the stuff from there and whatever. If it doesn't work as well as generating the Eclipse files from Gradle, then we can see what we got.
Yeah, I could
Cool.
try that out.
Sounds.
Cool.
Sorry, Hung?
He said
Yeah, I could try that looking out and see how it goes.
Cool, sounds good.
What
All
about
right.
my bad change though? I have no idea why I did that.
Yeah, I guess we'll finish this.
I
and-
cloned from the wrong. I definitely cloned from the wrong fork
We
instead of
can
my own
figure
fork.
it
I
out in a
cloned
minute.
from the.
Yeah, I guess you want to talk to Louis under the bus.
I anticipate there's going to be a bunch of that happening
Yeah, it's
initially.
Yeah.
it just needs a few words, I think, around the whole Git remote repos and the way it works, and just getting
No,
your
but
head around that.
What would be interesting though is if you, Louis, talk to Hung with the page I wrote,
Mhm.
because apparently I didn't do that well.
No, I think you did, but or did you look at that, Hung, or did you just do it on your own?
Oh well, Hung's gone.
Okay.
Anyways,
I'll-
we don't
I'll
need to
think
sort this out now. This is not relevant for the
Okay, then.
speaking. But so I'll let you guys do that.
Okay.
And on which I'm gonna close the issue. I'm gonna push this branch that I used for like the resilient cache, the Ehcache stuff. It's pretty easy. I added a couple of methods on the store interface. I've added a couple. No, and I overrode. Well, I didn't. Yeah, I didn't override actually. I implemented some of these methods on the Ehcache type, and I'll push that to my repo, hopefully. And so we have this as a trace, but the point isn't to merge it to master at all, ever. I think we should do the work when we do the actual work. Okay? Cool, I guess I'll stop broadcasting.